All right, so 6.4, we looked at simplifying rational expressions in 6.1. We know how to multiply rational expressions. We know that rational expression just means an expression with a numerator and a denominator, or anything with division in it, right? Or a fraction. So simplifying, multiplying, and dividing all used factoring, right? Now we are leaping from rational expressions to polynomial expressions, okay? So now we are dividing polynomials. We know how to multiply them, right? We know to add them and we know how to subtract them. Today, we divide them, all right? What you need to know. So remember, what all of this is saying is we know the rule for adding or subtracting fractions that have the same denominator, right? So this says a plus b over c equals a over c plus b over c. Another way to look at it is a over c combined with b over c becomes whatever these two were combined. Oh, thank you. Yeah. Let me know if I'm ever cutting in and out, because sometimes it's on my end. Is a plus b over c. Does that make sense? One second. I'm actually, now that you said that, I'm going to plug in my. Sorry, that was normal. Not what I meant. All right, should be good now. So we know we can split the dividend or the top. We can split the top up into separate components and divide each of the components by the bottom or the divisor. Okay, just like when we were dividing out greatest common factors. Good. All right. If I have a polynomial divided by a monomial, just means there's one term here, there's more than one term here, I split it up. What I usually do to split it up, if I have a plus b over c, the way that I split it up visually is I circle a over c, and then I circle b over c with the sign, because that sign goes with b. B is either a negative number or a positive number, right? So here, a is being divided by c, right? Is what I circled in the dark blue. And then b is being divided by c. So just different ways to look at it. They are split into individual fractions just to check, can I simplify this, right? If, for example, you have 4 plus the square root of 2 over 2, right? So I can take a over c. I should not have circled that, sorry. A over c is just 4 over 2. If I divide 4 by 2, I just get 2, right? So 4 plus the square root of 2 over 2 is actually, that just becomes 2. And then that plus sign actually goes with the square root of 2. So plus square root of 2 over 2. I don't think that one simplifies, but I'm just showing you that if one side simplifies, it's fine to leave it completely alone. So you can call this 4 plus the square root of 2 over 2. Or you can call it 2 plus the square root of 2 over 2. Because 4 divided by 2 is 2, and you still have that plus sign. You've still accounted for that 2 here by dividing. And then you've accounted for this one by just leaving it the same. So those are exactly the same value, okay? That is what you need to know when dividing a polynomial, or you have 2 or more terms on top, by a monomial. You have only one term on the bottom, okay? Let's practice it. We're going to take the first half divided by the bottom. Oh, I guess it's more than half. We're going to take the first term divided by the bottom, take the second term divided by the bottom, take the third term divided by the bottom. Very, very important that we keep the sign with the term. So that's a negative 15 we'll be dividing by 3a. That's a positive 36a that we'll be dividing by 3a. And that's a negative 12a cubed that we'll be dividing by the 3a, okay? So don't ignore that that's a negative 15. All right, here we have three terms, negative 12a cubed, positive 36a, and a negative 15. They're all being divided by 3a. We can separate them. There are three terms. So that means we have negative 12a cubed, or a to the third, over 3a. Use this sign to put in between it, plus 36a divided by 3a. That negative 15 just becomes a minus 15 over 3a, okay? So that's still there, and that just becomes a negative in front of the 12. It can be out here if you want, just like this one was out here and this one was out here, however you prefer it, okay? So we've turned a trinomial divided by a monomial into three individual fractions or separate fractions, right? Can I simplify these individual fractions? Okay. Can anything on the top be canceled out by a 3 or by an a or by both the 3 and the a? Okay. 3, we have a negative 12 a cubed over 3a. So that's a negative 12 over 3 and 3 a's, a over a, right? What can I divide out? If you want to, you can factor the negative 12 becomes a negative 3 times a 4, right? So that's one way to look at it. And the a's are just 3 a's over 1a. I'll write them again. A over a. Sorry, I broke my color scheme. And then we're just going to cancel out, okay? We got a 3 and a 3. They're canceled. The negative isn't canceled because it wasn't a negative 3 divided by a negative 3. It's just the 3 and the 3. So the negative now goes with the 4. One of the a's is canceled out. Okay, so that becomes 4a squared because, oh, sorry, a negative 4a squared. Or if it's easier for you, you can just say negative 12 divided by 3 is negative 4. Okay. Or you can factor it into a factor that is common to the top and the bottom. So a factor that would be common to the top and the bottom is obviously 3. 12 divided by 3 is 4. Or I can factor out 3. 12 becomes 3 and 4. And I cancel out the 3's. Okay. The a to the third divided by a, you can do it this way, or you can just think, I know the rule for dividing polynomials is keep the base, subtract the exponent. 3 minus 1 is 2. Okay, whichever way is easier for you. Let's go on to the 36a divided by 3. Again, here we said negative 12 is a negative 3 times a positive 4. 36, if I divide it by 3, is 12. There are other factors of 36, right? You can divide it by 6, but that doesn't help us. Factoring it to 6 times a doesn't help because we don't have a 6 down here. We have a 3. So we want to take 36 and divide it by 3. So 36 divided by 3, we said is 12. So if 36 factors to 3 times 12 times a over 3a, right? What can we cancel? We can cancel the 3 and the a, and we're just left with 12. So that's a positive 12. Sorry, my spacing is 4. So because that's a plus, because that was a negative, we canceled out a positive 3. So we're keeping the negative, still negative 4a plus 12 because that was a plus. 15 and 3. Doing the same thing, right? Negative 12 became negative 3 times 4. Positive 36 became 3 times 12. 15, if I'm wanting to factor it into groups of 3, 15 becomes 5 times 3, right? There are no A's, so 5 times 3 over 3A. I can still cancel out the 3.
Isn't it
this
negative?
becomes 5 over A. And that's a perfectly fine answer, okay? So my final answer, all simplified, is negative 4A squared plus 12 minus, just carry that minus 5 over A. So in this case, everything factored out of the bottom. In this case, everything factored out of the bottom. In this case, it did not, so we're just leaving it as a fraction. So we have negative 4A squared plus 12 minus 5A, because we had the negative was kept, the 4 was kept, 2 of the A's were kept, so that's how we got that number. The 3 was canceled, the A was canceled, so we just had a 12 here. And then here we had a 5 on top and an A on the bottom left over when we canceled out the 3 on the top and the 3 on the bottom. Okay. All right, here, another example. 10t to the 4th minus 35t to the 3rd plus 5t squared divided by 5t squared. Okay, let's separate it out. So we have 10t to the 4th over 5t squared. What I can change that to is 10 is 5 times 2, right? There are 4 t's, or I'm just subtracting if that's easier for you. 5 and 5, because I want to keep that, okay? And there are 2 t's. Now I can cancel out the 5's, I can cancel out the t's and the t. What I'm left with on top is 2t squared, because there are 2 of them. Good. All right, next one. Minus 35t cubed over 5t squared. Just look at, we took the 10 and we factored it by 5. It's going to be helpful to take the 35 and factor it by 5. And you can just keep the negative as a sign, okay? Don't overthink it. If it's negative here, it's going to be negative here. Good? Negative 35t cubed over 5t squared. A 35 becomes 7 times 5, right? And then you have 3 t's, t times t times t. And then you have 5 and you have 2 t's. Or you're subtracting 3 minus 2 is 1. That's a fine way to do it as well. Let's see what we have. We cross out the 5's, we cross out the t's, we cross out the t's. What we end up with is 7t, and everything's canceled on the bottom. So always make sure you did cancel out everything on the bottom. Good. So we have 2t squared minus 7t because that was a negative. Okay. Or you could say it's a negative 35. Then that's a negative 7, positive 5. You cancel out the positive 5s. You still have that negative 7. Okay. And plus 5t squared. Ooh, 5t squared divided by 5t squared. What do you think is going to happen? They are prime factors, but they cancel each other out, right? It's going to be 5 divided by 5 times t divided by t times t. So that means everything cancels. Do not call it 0. Okay. We're just calling it 1. Good. Anything divided by itself is an understood 1. So let's look at 5 divided by 5. Oh, I'm sorry, you couldn't see that. 5 divided by 5 is 1. It's not 0, okay? If everything were to cancel out on the bottom, we're not saying that this is 7t divided by 0, right? It's not a 0 down here. It's actually a 1. 7 divided by 0 is going to make an answer that you cannot, that doesn't even exist, okay? But 7 divided by 1 is just that original 7. So when you're dealing with fractions and everything cancels, it's never cancels to 0, it cancels to 1 over 1 or 5. We don't know what t is, but let's pretend t is 2, right? 5 times 2 squared. I have to say all divided by 5 times 2 squared divided by 5 times 2 squared. You're going to get 1. Okay, no matter what that x is, it's going to be that, or what that t is, it's going to be the same t on the top and the bottom. So whatever that number is, it's going to give you 1 because it's itself divided by itself. Okay, and 1 divided by 1 does not become 0. 1 divided by 1 is still 1. Good. When we're dealing with fractions, it never disappears to 0. It disappears to 1. Good. So we said negative 12 divided by 3 is 4. That's not negative 4 over 0. It's negative 4 over 1, right? Negative 12 divided by 3 is negative 4. Negative 4 over 0 is not what negative 4 is, but negative 4 over 1 is what negative 4 is. So when you cancel everything out on the bottom, you just leave a 1 on the bottom. When you cancel everything else on the top, excuse me, you leave a 1 on the top. If you leave a 1 on the top and a 1 on the bottom, it's just a 1. Good. So this answer is 2t squared minus 7t plus 1. That is okay. We are recording it. I remember to record it. All right. Now, what if it is a polynomial divided by a polynomial? All right. What to do when the denominator is not a monomial? It follows from the skills of long division for individual numbers. And I know that that's not a fun skill. But you can do it. We can do it. So, for example, if you had the number 525 and you wanted to divide it by 3, okay? What you do, right, is we take that first number and we look at what we're dividing it by. So it's 525, but we're really just looking at the 5 and the 3. And we're thinking, how many times does the 3 go into the 5? So I know this is like 4th grade, 5th grade. I don't remember. Ask you to reach pretty far back. We're looking at the 5 and saying, how do I make that 3 of 5? How many times does 3 go into 5, right? And if you don't know, you can just say 5 divided by 3 is 1 and something, okay? We want a whole number, so we're just going to pick the number 1. Ignore all the decimal, okay? How many times does 3 go into 5? It only goes in 1 time because 3 times 2 is 6. 6 is bigger than 5, right? So we're going to put that 1 up here. We're going to put the 3 down here. And then, okay, very important, the thing I even forget is we now subtract that number from the 5. So 5 minus that 3 that we got for saying 3 times 1 is 3. Okay, so you put the number up here, then you multiply that number by this and put it down exactly below the number we were talking about, which is the first term we were talking about. Sorry, saying number when I mean term. We put it directly below the term we were talking about. So 1 times 3 is 3, and then we turn it to a negative 3. All right, so 5 times negative 3 is, or sorry, not 5 times, 5 minus 3 is 2. Okay, we know that 3 is not going to go into 2, right? That's less than 3. That's less than 1. And that's how we got, that's why we had to stop, right? Now you're going to bring down your next term. So instead of 2, we now have 22, okay? Take 22 divided by 3. How many times can 3 go into 22? It can go in 7 times. Good. So now we have the number 22. And we're looking at 3. 3 can go into 22 7 times. Okay. What is 7 times 3? 7 times 3 is 21. It goes right below it. And again, it gets subtracted. 22 minus 21 is just the number 1, right? Too small to be divided by 3. So we're going to bring down the next number. The next number is a 5. And this is how you long divide. It takes forever. It seems complicated, but that's how you do it. 15, we do not subtract. You do subtract on the second one. 15 right? And you think, how many times does 3 go into 15? Or what is 15 divided by 3? It is 5. So now you're going to write that 5 right next to the 7. 5 times 3 is 15. And now is when you subtract. I apologize. 15 minus 15 is 0. So your remainder is 0. Is it true? What you're going to do is 525 divided by 3. 525 divided by 3 is 175. Good? Because 175 times 3 is 525. So that's what we're doing if your division problem has more than one term on the bottom. Okay? So let's look at these examples. So here we are taking 7,256. We're dividing it by 43, right? What we want to do is we want to look at 7 and 43. Well, 43 is obviously not going to go into 7. So we're going to look at 72. If I take 72 and I divide it by 43, what do I get? 72 divided by 43. What do I multiply 43 by to get close to 72 without going over? Yeah? Just the number 1. So 72 divided by 43 is going to be 1. We're going to take that 1 and we're going to multiply it by the 43 and put it exactly below the 72. So I'm just giving another example, just like 525 divided by 3. Okay, just another example. 1 times the 43 is 43. 72 minus 43. Again, remember, you're subtracting. 72 minus the 43. 72 minus 43 is 29. That's how we got that 29. Okay. Now, I can't take 29 and divide it by 43, right? So I'm going to bring down the 5. Now I'm going to take 295 and divide it by 43. 295 divided by 43 is 6.8. Don't look at the decimal, just 6. Okay, so that's where we got this 6. Because 295 divided by 43 gives us 6 and something. Now you take that 6, multiply it by the 43, and it's going to give you 258. That 258 is written right here, and we subtract it. Okay? 295 minus 258 is 37. Good. I can't take 37 and divide it by 43, right? It's not going to give me 1, and I would need it to give me at least 1. It doesn't. So I'm going to bring down the 6. Yeah, the 6 has been brought all the way down. So now I have 376, and I'm going to divide it by 43. 376 divided by 43 is the same as, what do I need to multiply 43 by to get to 376? I need to multiply 43 by 8.7441860, etc. Right? So stop. We're not including decimals, just whole numbers. So that whole number is 8, right? And so that's how we got that 8. We said that if I take 376 and divide it by 43, I get 8 something. Okay? 8 times 43 is 344. 8 times 43 gives me this number. Okay? I subtract it again. 376 minus 344 is 32. I can't take 32 and divide it by 43, right? If you can't do that and there are no more numbers to bring down, you just say remainder 32, or you say it's 168 and 32/43. Okay. Notice how 43 is the number you were dividing by. Just like here, we could not cancel the A, so we left our last number over A, right? We couldn't cancel out that A because there was no A on the top, so that A is going to remain on the bottom. There's no way to cancel it out. So we can say it's negative 4A squared. We can say it's positive 12, but then we have to say it's negative 5 over A, okay? Here we got 168, but then we had 32 left over. And so we leave it over what we were originally dividing by. And this, okay, this is the horizontal way to do division, right? But vertically, what it would look like is 7, 2, 5, 6 is being divided by 43, right? So what we get is that it goes in 168 times, but then you have 32 left over. And so you divide it by that same 43. 168 times 32/43 looks like this. Okay. Oh, sorry. I said multiplying, it should be add. 168 plus this fraction gives a 168.744186. Okay. If I just divide 7,256 divided by 43, I get that exact same number. Okay. So it's just another way to write this fraction. This fraction is the same as writing it so this is vertical up and down. This is horizontal, left to right. And then this is our answer. That's as close as we could get to our answer. You can also just call it 168 remainder 32. Good. All right. So that's just that's doing long division on a number, right? That's from previous math classes. Yeah. Now we're going to take 28x squared minus 23x minus 15, and we're going to divide it by 7x plus 3. Okay. These are the same skills for this problem. Okay. You are still going to want to look at, so here we looked at 7 and 43. We couldn't use 7 and 43, so we went to the next term. So we started with 7. It's too small. 72, that's big enough. 72 goes into 43, 43 goes into 72 one time. 1 times 43 is 43, right? Exact same thing here, okay? So just like we were looking at 72 and 43, now we're going to look at 28x squared and 7x, okay? Just look at your first term. 28 and 7, you can just divide it. 28 divided by 7. Ooh, that's nice. It's a 4, right? X squared and x. So you can do it vertically if you want. So we have 28 over 7 becomes 4. And we have x squared over x, which becomes x, right? So that's kind of nice. If I take 7x and I multiply it by 4x, I get exactly 28x squared. Good, because it was 4. 28 by 7 is 4, and x squared divided by x is x. So 28x squared divided by 7x gives me 4x. Sometimes it won't be that even, that's okay. So now you go back and you say 4x times 7x. 4 times 7 is 28. X times x is x squared. Okay. Now you have to take that 4x and you have to apply it to the plus 3 as well. So now 4x, 4 times 3, 4x times 3. So 4 times 3 is 12. and then you have that x, okay? Ignore these minuses. That just means we're going to parentheses subtract it all, okay? But basically, you are only looking at the first two terms. You're choosing what term helps 7x become 28x squared, but not go over it. Then you're taking that term, that 4x, and you're multiplying it by both, okay? So 4x times 7x becomes 28x squared. 4x times a positive 3 becomes a positive 12x. These just mean that we're going to subtract both of them, right? We're subtracting, just like we subtracted the 43, we subtracted the 258, we subtracted the 344. So 28x squared minus 28x squared, they cancel out. Because we're subtracting them both, that plus 12x becomes a negative 12x, right? Because we are saying that that's a negative 1 times positive 28 squared. We're distributing negative 1 times positive 28x squared and negative 1 times a positive 12x. So they both become negative because of this subtraction, right? So negative 28x squared minus 12x. So now we have a negative 23x minus 12x. You're just combining them. You're not multiplying. So you have a negative 23 minus 12, right? That becomes negative 35. So negative 23 minus 12x is a negative 35x. And that is what you're now going to look at with your 7x. Okay? So now you have a negative 35x and a 7x. You don't need to worry about the 3. You're just looking at the first terms. A negative 35. How many times does 7 go into negative 35? Oh, it happens to be negative 5, right? And they both have an x. So 7x times negative 5 is going to give me exactly negative 35x. So I'm going to write that negative 5 up here. And then I'm going to take that negative 5. I'm going to multiply it by the original 7x, and I'm going to get negative 35x, right? I'm going to take that negative 5, and I'm also going to multiply it by the positive 3, and I'm going to get negative 15, right? These become positive because just like here we subtracted it, we subtracted it, we subtracted it. Now we need to subtract that. Okay, and so that's how those become pluses. I just wanted to explain it a little bit better than that picture. So minus a negative 35x minus a negative 15 becomes, we're adding 35x and we're adding 15, right? To this negative 35 and to this negative 15. And so that becomes 0. So that's remainder 0. When I take 28x squared minus 23x minus 15 and I divide it by 7x plus 3, I get 4x minus 5. Okay.
I love
right.
children.
Example 3. Leave a space if anything is skipped. Okay. Make sure that you have, this is an exponent, or sorry, c raised to the second power, c raised to the first power, c raised to the 0 power, right? And here c is raised to the first
I
power,
love
here c is
children.
raised to the 0 power. So look at the first term of what you're dividing by and the first term of what you're dividing into. Okay, so this is c squared plus 3c minus 2. You're dividing all of that by c plus 1. Okay, look at your first term. Here, our first term is c squared and c. What do I need to do to c to get a c squared? I just need to multiply it by c. All right. Now I take that c, I go back, I multiply it by the c, and I distribute it to the 1. So c times c is going to be a c squared. C times 1 is going to be a positive c, right? However, do not forget we're subtracting. So we have to distribute that negative to both. So that becomes negative c squared minus c. Okay. And you don't have to rewrite it if it's easier for you to keep it and just know that you're distributing it and write over it. That's perfectly fine, of course. C squared minus c squared, those cancel out. Positive 3 minus 1, right? If there's no number in front of it, there's just one C. So here we were multiplying, here we're adding and subtracting. Here we're multiplying, here we're combining, okay? Adding and subtracting. So 3. One sec, guys. Oh, you guys are so nice. All right, cancel those. 3 minus 1, just a 2, okay? So it's confusing because you're multiplying here, you're combining here. 3 minus 1 is just 2. Now you have a C plus 1 and you have a 2C. Because you have 2 terms here, you need to bring down that -2, okay? We're going to be done soon because we did the squared, we did the C, and now we're on to the constant. So you have 2C minus 2. What, again, we're looking at now the first term and the first term. C times 2C, C and 2C, right? What do I need to do to C to make it 2C? I just need to multiply it by 2, okay? So it's just C and a positive 2, so it's going to be C plus 2. Take that 2, multiply it by C. 2 times C is 2C. 2 times 1 is 2. They were all positive, so it's a positive 2C and a positive 2. However, don't forget, we're subtracting them. So you can go like this, subtract, or you can write over it, whatever you want. So now we have 2C minus 2, and being subtracted from that, 2C minus 2C cancels out. -2 minus 2 does not cancel out. It becomes a -4, right? Because we're adding 2 negatives, so it just becomes a bigger negative, -4. So what your final answer is, no, it's okay. What your final answer is C plus 2 remainder 4. I'm pretty sure that my math lab asks for a remainder. If not, you just say C plus 2 plus, remainder -4. Ignore that I just said the word plus. C plus 2 minus, good, 4 over whatever you had right here. 4 over C plus 1. Okay, we got that first term, we got out of C. That second term, we got out of 2. I know it doesn't make perfect sense like it did when we were, when it was a monomial down here. We got a 2. Here we had a remainder, so we're leaving the C plus 1 on the bottom. So we have C plus 2 minus 4 over C plus 1, or C plus 2 remainder -4. Here is vertical. Here is horizontal. So that's y squared minus 5y plus 6 divided by y minus 2. So that would look like this. If it was up and down, not that that matters. Okay, there's many ways to write it, or this way, or inside the house, right? Y squared minus 5y plus 6, y being divided by y minus 2. I know we don't have much time, but we can do it. All right, this is y squared, y, and a constant. So that means you're in order. If it wasn't in order, you would need to leave a space, but we can talk about that. That doesn't really come up. Example 6 for example 7. All right, so y squared, you're just looking at the y squared and the y. To get y squared from y, you just need to multiply it by y, right? So y times y is that y squared. Y times -2 is a -2y. Good. Make sure you subtract it. So that becomes -y squared plus 2y, right? Those cancel. -5 plus 2 becomes a -3y. That's all you need to do. This has 2 terms, so make sure here you have 2 terms. So you're going to bring down the 6. Now, -3y into y. What do I need to multiply y by to get a -3y? Just a -3. Negative 3 times y becomes a negative 3y. Then negative 3 times the negative 2 becomes a positive 6. Good. Negative times a negative becomes a positive 6. However, as always, we're subtracting it. Okay, so negative 3y minus a negative 3y means negative 3y plus 3y, and that becomes a negative 6, right? So negative and a positive of the same cancel each other out, and then we have a positive 6 minus 6, so that's a 0. So y squared minus 5y plus 6 divided by y minus 2 is y minus 3. Final answer. So if you take y minus 2 and y minus 3 and you multiply them together, you should get y squared minus 5y plus 6, just to like reconnect to all the factoring that we've done. I know we only have 4 minutes left, so we will save examples 5, 6, and 7 for Friday. I'm going to stop recording.